Good morning students. Welcome to 11th standard chemistry video class. In this video, we have to start with the new lesson 10 chemical bonding. In this lesson chemical bonding, first we will start with introduction. Introduction to the lesson chemical bonding. Diamond and graphite are allotropes of carbon, in which diamond is very hard and graphite is very soft, where gases like hydrogen and oxygen are present in diatomic form, while inert gases are present in monatomic form. Here, carbon combines with chlorine to form carbon tetrachloride with the formula CCl4, which is a liquid and it is insoluble in water. Next one. Sodium combines with chlorine to form sodium chloride, where this sodium chloride is hard and brittle compound, and this sodium chloride is readily dissolved in water. The reason for the above said observations is the type of interaction made between atoms of these molecules. Hence, this interaction are responsible for joining the atoms or ions in the molecule. Here, the interaction are otherwise called interatomic forces, which hold the constituent atoms or ions together in a molecule are called chemical bond. Here, the interactive force which acts between atoms in a molecule is called chemical bond. It is the definition for chemical bond. The last 4 lines of the paragraph gives the definition for chemical bond. Next one. Why do atoms combine only in certain combinations to form molecules? It is explained with examples. Whenever oxygen combines with hydrogen, it forms water with the formula H2O. Again, oxygen combines with carbon, it forms carbon dioxide with the formula CO2. Here, the structure of water is V-shaped, while the structure of carbon dioxide is linear. The reason for the above concept to be explained by chemical bonding. In this lesson chemical bonding, we have to discuss various theories and their principle to explain the nature of chemical bonding. Next topic, Coastal-Levi's approach to chemical bonding. A logical explanation for chemical bonding was provided by Coastal and Lewis. The concept of chemical bonding is based on the inertness of noble gases. Already, we know that noble gases have completely filled stable electronic configuration. Therefore, noble gases have little tendency or no tendency to combine with other atoms, since they are in stable electronic configuration. We discussed that noble gases are stable due to their completely filled outer shell electronic configuration. Here, the elements other than noble gases try to attain noble gas configuration or completely filled configuration. In order to attain completely filled configuration, the elements may lose, gain, or share one or more electrons from their outer shell. It is explained with an example. Here we will discuss the formation of sodium chloride. Sodium chloride with the formula NaCl. Consider sodium with atomic number 11. The electronic configuration can be written as 2, 8, 1. In order to attain noble gas configuration, it loses its valence 1 electron and forms Na plus ion with electronic configuration 2, 8. Here, the Na plus ion with neon stable electronic configuration. Consider chlorine with atomic number 17. The electronic configuration can be written as 2, 8, 7. In order to attain noble gas configuration, it gains 1 electron and forms Cl minus ion with electronic configuration of 2, 8, 8. Here Cl minus ion with argon stable electronic configuration. Here electron lost by sodium is gained by chlorine. Both atoms attains nearest noble gas configuration. The formed ions, namely Na plus and Cl minus, are held together by electrostatic attractive forces, and hence this attractive forces is said to be chemical bond. Here the bond formed between Na plus ion and Cl minus ion is electrovalent bond or ionic bond. Hence there should be strong force of attraction made between Na plus ion and Cl minus ion. The formation of sodium chloride is shown here. Next, the scientist G.N. Lewis proposed that the attainment of stable electronic configuration in molecules such as diatomic nitrogen, oxygen, etc. is achieved by mutual sharing of the electron. If a bond is formed due to mutual sharing of electrons, then it is said to be covalent bond. In order to represent the chemical bond and the electrons present in the outer shell of an atom, Lewis introduced a simple structure. It is called Lewis dot structure. Here, the valence electrons, that is, outer shell electrons of an element, are represented as small dots around the symbol of the element. The first 4 valence electrons are placed as single dots around the 4 sides of the atomic symbol, and the 5th electron is get paired with any one of the single electron or single dot. Here single dot represents 1 electron. Consider nitrogen. Nitrogen with atomic number 7. The electronic configuration is given by 1s2, 2s2, 2p3. The valence shell configuration is 2s2, 2p3. Hence, it contains 5 electrons in their outer shell or valence shell. The Lewis structure for nitrogen is given here. First, we have to write the symbol of nitrogen. It is written as N. It contains 5 electrons in their valence shell. First, we have to place 4 single dots around the 4 sides of the atomic symbol, and the 5th electron is paired on any one of the single dot. Lewis structure of nitrogen atom is shown here. Similarly, we are having Lewis structure for carbon and oxygen. It is also shown here. The only exception to this is helium, which has only 2 electrons in its valence shell, which is represented as a pair of dots, that is duet configuration. Lewis structure of helium atom is shown here. Next, we will discuss octet rule. Here, we are having the statement for octet rule. The atoms transfer or share electrons so that all atoms involved in chemical bonding obtain 8 electrons in their outer shell or valence shell, or otherwise all atoms which is involved in chemical bonding should have 8 electrons in their outer shell. For that, the atom may transfer or share their electrons. This statement is said to be octet rule. It is an important question. If they ask state octet rule, you have to give this paragraph. Next topic, types of chemical bonds. Based on the nature of interactive force which is acting between the bonded atoms, the chemical bonds may be classified into two major types, namely ionic bond and covalent bond. Ionic bond is formed by the reaction of metal with non-metal, where covalent bond is formed by reaction of non-metals. First, we will discuss covalent bond. Covalent bonds. What is covalent bond? The definition for covalent bond is given here. Mutual sharing of one or more pairs of electrons between two combining atoms results in the formation of a chemical bond called a covalent bond. Again, I repeat the definition for covalent bond. Mutual sharing of one or more pairs of electrons between two combining atoms results in the formation of a chemical bond called a covalent bond. If they ask define covalent bond, you have to give this answer. Here we have to explain covalent bond by taking three examples: formation of hydrogen molecule, oxygen molecule and nitrogen molecule. Consider hydrogen molecule. Whenever two hydrogen atom combines together, it forms a hydrogen molecule. Hydrogen with atomic number 1. Here each hydrogen atom with one valence electron. In order to attain nearest noble gas configuration, the two hydrogen atom undergoes mutual sharing of one electron and hence it forms covalent bond between two hydrogen atom. Here one pair of electron is shared, hence it forms single bond. Single bond is formed in hydrogen molecule. It is shown here. Consider oxygen molecule. Whenever two oxygen atom combines together, it forms a oxygen molecule. Here oxygen with atomic number 8. The electronic configuration is 2, 6. Each oxygen atom contains 6 electrons in their valence shell. In order to attain nearest noble gas configuration, both the oxygen atoms shares 2 electron pairs. If 2 electron pairs are shared between two combining atoms, it forms double bond. Hence, double bond is formed in oxygen molecule. It is shown here. Next one, nitrogen molecule. Whenever two nitrogen atom combines together, it forms a nitrogen molecule. Nitrogen with atomic number 7. The electronic configuration is 2, 5. Each nitrogen atom contains 5 electrons in their valence shell. In order to attain nearest noble gas configuration, both nitrogen atom shares 3 electron pairs. If 3 electron pairs are shared between two combining atoms, it forms triple bond. Hence, triple bond is formed in nitrogen molecule. It is shown here. Hence, if two atoms share just one pair of electron, a single covalent bond is formed. Example, hydrogen molecule. If two electron pairs are shared between the two combining atoms, then the covalent bond is called double bond. The example is oxygen molecule. If three electron pairs are shared between the two combining atoms, then the covalent bond is called triple bond. The example is nitrogen molecule. Let us stop up to this topic. The remaining that we will discuss in our next video class. Thank you.